Okay, before we start on the ER diagram, there's one thing I want to think about, and that is we have a store table, and we're going to have S followed by a number. We've got a disk table, and we're going to have D in front of that followed by an integer, and we're going to have a generic video. Maybe I should call that M for movie instead. Just try to keep things more clear. It's going to be a letter followed by a number, and we're going to have a rental that's going to be an R followed by a number. So the question is, do we really need to make that letter part of the key? Or can we just use numbers, which would be much more preferable in terms of speed and efficiency? Anytime we pull an ID number from the store table, we could pull the integer and then just put an S in front of it to make things clear for the user. Same thing with all of the other ones. So this part's a little bit sneaky, and if you didn't do this on your homework assignment, that's fine. But when I design my entities, I'm just going to use an integer for the key. And then just know that anytime we need to present those keys to the user, if we're pulling a key from the store table, we'll put an S in front of it. If we're pulling it from the disk table, we'll put a D in front of it. And if we're pulling it from I'm going to call it the movie table, we'll put an M in front of it. And if we're pulling it from the rental table, we'll put an R in front of it. Okay. Let's take a look at our dependencies here. And so we've got a store, obviously. We've got a member, obviously. We have a movie and then catalog, and I think I'm going to change that to disk. Oh, I'm sorry. No, I'm not. I have a disk ID for an individual disk. And then we will have an actor table. It's not going to have much in it. We'll have a rental table. So every one of these dependencies here, it looks like is going to create its own table. So let's flip over and start creating our tables. And to save a little bit of time here, I'll just stop the video and put in the tables, and then we'll talk about them after we've got them inserted. Okay, I didn't bother to put in all of the other fields. The only things that I bothered to put in were primary keys and, well, except over here, primary keys and foreign keys. So let's take a look at some relationships here. A store can have many disks, okay, but a disk only has one store. So we're going to have a many to one, linking the store ID here to the store ID here. So we start on the many side with store ID, go to the one side with store ID, and so that's our relationship. Does a disk have to have a store associated with it? Yes. Does a store have to have a movie associated with it? And whether you put a 0 or a 1 in there, I guess depends on if you're starting off with an empty table at the beginning, you wouldn't have to have something in here. And actually, this is an intersection table, pretty much. Now, a disk over here can have many movies. I'm sorry, a disk over here can have one movie, but a movie can have many disks. So this is the many side. So we're going to do another one to many. Start on the many side with the movie ID this time, and click on movie ID over here. And so when we pause the mouse over the relationship, we see movie ID lit up on both sides. When we pause the mouse over this relationship, we see the store ID lit up on both sides. Now, movie has a relationship to actor, not disk, but movie. So a movie can have many actors, and an actor can have be in many movies. So this is going to be a many-to-many relationship. So we're going to click on the movie ID up here and the actor ID down here, and I'm going to need to stretch these apart a little bit. Okay. So does a movie have to have an actor? Maybe not. If you have a bunch of unknowns, you might not put them in your database, so that one's kind of optional. When you've got an intersection table here, though, this actor has to be over here, so this is going to be a required hash mark for the cardinality. And the movie ID has to appear over here, so this is going to be a required cardinality as well. So we do need 2 hash marks there and 2 hash marks here. And then the movie, this we could argue about. And let me see, does the actor have to be in there? And you could argue about that one. So either a hash mark or an oval, either one will do, I think, on this end or this end. And you could make arguments either way. And then we have a member, and a member can rent. Now, the one entity that was missing here is the rental, and a rental is when a member and a disk get paired together. So the member does not rent the movie, the member rents a specific disk. So that's going to be a many-to-many. And we are going to, okay, so it's going to be the member ID paired up with the disk ID. And then we're going to change the name of this to rental. Okay. And then we need to decide. So this is an intersection table, which the disk ID has to be up here and the member ID has to be down here. So we're going to have 2 hash marks here, we're going to have 2 hash marks here. Does a disk have to be rented? Not necessarily. So let's go in on that. And does a member have to have a rental? Not at the beginning, they don't have to. So we can put them in our database without having to have a rental in there. So we're going to go in and we're going to take a look at this relationship. We are going to click on the foreign key part here. And what we have here is on the rental side, a member does not have to have a rental. So we should click on that, close that, and we should see a bubble appear there, which we do. And a disk does not have to have been rented. So let's double click on this one. Let's go to foreign key. And the rental is the many side. So we are going to make that so it's not mandatory, and that should turn into a bubble up there too as soon as I close this window down here. There we go. Okay, took a while, but we got there. So this is, I think, what you should end up with. Obviously, we'd have the other fields in there, but those other fields aren't nearly as important as identifying the entities that we have, the keys for each entity, and the relationships between them.